All right, you guys, this is Concentrations and Dilution lecture video 7, and I am still on page 535, and we are going to look at number 2. So number 2 says that they want us to prepare 500 milliliters, 5% Curacao solution from a stock solution of Curacao 1 to 10. So the first question that you ask yourself, you are to ask yourself, what type of problem is this? Well, based off of what is given, you have two concentrations. One concentration is expressed in a percentage, which is 5%, and the other concentration is expressed as a ratio, which you guys have 1 to 10. So this problem, this is a dilution problem. All right. Remember, when determining what type of problem it is, you look at the amount of concentrations you have. If you have one concentration, that means it's a concentration problem. If you have two concentrations, that means it's a dilution problem. And if you have three concentrations, that means it's an alligation problem. But regardless of how the concentrations are expressed, whether it's expressed in a ratio, a fraction, or a percentage, keep in mind that the number of those concentrations, however many times they're expressed as, depends on the type of problem it is. So now that you have determined the type of problem, you now need to identify your dilution components. All right. So in order to do that, we need to determine, what's C1, what's Q1, what's C2, and what's Q2. Well, the question is, what's the definition of these four components? Well, a C1 means it's the stock concentration, C-O-N-C-E-N-T-R, concentration. So if you look at the problem, read the problem again. It says prepare 500 milliliters, 5%. Well, let's stop there. Whatever you're preparing is your desired. Anything else will be your stock. So it says to prepare 500 milliliters, 5% solution from a stock solution of 1 to 10. All right, so remember, I told you that your C1 is your stock concentration. In the problem, it tells you your stock solution of a 1 to 10. So that means that the 1 to 10 is your concentration. But remember, you have to work with whole numbers. So you have to change that 1 to 10 to a percentage by taking 1 over 10, changing the ratio to a fraction, and multiplying that fraction by 100. So that means that 1 to 10 ratio is 10%. All right. Now, your next thing is Q1. What's your Q1? Well, if I read the problem again. Prepare 500 milliliters, 5%. 500 milliliters, 5% is what I'm preparing. That's my desired. All right. Your Q1 is your stock quantity. You do not have that in this problem. It's telling you to prepare 500 milliliters, 5% from a stock solution of 1 to 10. It doesn't tell you how much of that stock solution, so your Q1 is X. Your C2 is your desired concentration. Well, you know your desired concentration. What you're preparing is 500 milliliters, 5%. 5% is your concentration. And your Q2 is your desired quantity. Well, based off of the problem, you're preparing 500 milliliters. All right. So now that you have determined what your components are, now you can solve the problem. The first A says how many milliliters of stock solution are necessary for this preparation. In order to solve that, you're going to have to use your dilution formula, which is, you guys know it, C1 times Q1 equals C2 times Q2. So my C1, you guys know, is 10. All right, my Q1 is X equals, my C2 is 5, and my Q2 is 500. All right, so that's 10X equals 5 times 500 is what? 2,500? Make sure that my answer is right. You are going to divide 10 on both sides. Let me go ahead and use my pen here. You're going to divide 10 on both sides. Get X by itself, and your answer is 250 milliliters. So you're going to need 250 milliliters of the 10%. All right. Well, the next question, your next question, B says how many milliliters of solvents are necessary for this preparation. When it's asking you for how many milliliters of solvent, in detail, they want to know how many milliliters of your base. They want to know how much of the preparation of 500 milliliters is of base. That base can be anything. That base can be water. It can be normal saline. It could be whatever it is. So whenever it asks for the solvent, solvent basically means how much of the medication is base. In order to solve that, you must use the following formula. You're going to take Q2 minus Q1, which equals your solvent. So we already know that our Q2 was 500 milliliters. Your Q2 is your desired preparation, whatever you prepared. And you're going to subtract that from your Q1. You guys have already determined that your Q1 was 250 milliliters. So that means that 250 milliliters of this preparation or of this medication is of solvent. All right. Alrighty. So this is going to be the last lecture video for concentrations and dilutions. I want you guys to keep practicing your problems. But before I end, let's just go over a couple of things. Remember, concentrations concentrations can be expressed three ways. You have a ratio, you have a fraction, and you also have a percentage. All right? Concentrations also come in three different types. There are three types of concentrations. Those concentrations are weight to weight, which means it's in grams per grams. You have weight to volume. Weight to volume, which means its units is grams per milliliter. And then you also have volume to volume, which means that its units are in milliliter per milliliter. So, if I were to ask you to write 10% in a ratio of weight to volume, you will rewrite this as 10 grams to 100 milliliters. That makes sense. Again, if I want you to write 10% in a ratio of weight to volume, you're going to rewrite it as 10 grams to 100 milliliters, because remember, weight has to be in grams and volume is in milliliters, because remember, your units for weight to volume, I just told you, is gram per milliliters. If I ask for you to write 5% in a fraction of weight to weight, you will write or rewrite this as I'm going to pull out my pen so you guys can see it. So in order for me to write 5% in a fraction of weight to weight, I'm going to write it as 5 grams to 100 grams. It's in the fraction form. 5 over 100. And my units have to be grams per grams, because I'm doing what? Weight to weight. What if I ask for you to write the fraction 8 to 25 in a ratio form of volume to volume? How would you rewrite that? Well, you will rewrite it. You'll rewrite the fraction 8 over 25. You'll rewrite it in the fraction 8. If it has to be volume to volume, it should be 8 milliliters to 25 milliliters. All right. So this here, when we talk about concentrations, the three ways they're expressed as and the three types of concentration, that does not change. All right. You just need to be able, when you read a problem, you should be able to identify what's a concentration, what's a dilution, what's a percentage. You should be able to also change between fractions, percentages, and ratios. The reason being is because when you're solving these problems, you have to work with whole numbers. So you can't work with a ratio. You can't work with a fraction. You're going to have to change your ratio and fractions to whole numbers. Change them to percentages, just like I did here. It came in a 5% and I have a 1 to 10. I have to rewrite this as a percentage, because a percentage